Hello, everyone. Welcome. In the last chapters, we introduced the BCS and showed you how to deploy a simple BCS instance. Today we return to look deeper into BCS operations. Let's look at how to compile, deploy, and instantiate a chain code. First, what is a chain code? Also called a smart contract. A chain code is an event-driven, stateful program stored and running on a blockchain. A smart contract is triggered and executed when preset criteria and rules are met. The ultimate goal of smart contract execution is to generate ledger data in blocks. In other words, all operations on ledgers are performed by smart contracts. We can think of a chain code as the only thing that can generate transactions. A ledger consists of many blocks, and each block contains the data of one or more transactions. This basically means that each transaction is completed using a smart contract, and ledgers are updated using underlying blockchain technologies. Next, let's look at how chain codes and the transaction process work. Here are some basic concepts. A channel is also called a subchain. A channel can include peers of different organizations, and a single peer can be added to different channels. All chain code operations take effect across their entire channel. That is, operations are performed on all of the peers in a channel synchronously. Fabric divides nodes into three types: endorser, orderer, and committer. An endorser separates computing tasks to relieve orderer burdens and to increase overall system throughput. An orderer reaches consensus on the chain code execution resultant. We support different consensus mechanisms such as Solo, Kafka, and Byzantine algorithms. A committer writes chain code execution results into the ledger and synchronizes the results to all peer nodes. A peer can function as both an endorser and a committer. The figure on the right shows the basic transaction process. Our application integrates the Fabric SDKs and obtains the authentication certificate from Fabric CA. When a transaction occurs, the application uses the SDK to submit a proposal to the peer node called a transaction plan. The peer performs a preliminary check, like checking the signature on ACL for instance, and then simulates the transaction execution. It executes the chain code, signs the execution result, and returns the result to the SDK. After the SDK receives the returned results of all the endorsing peers for multiple transactions, the SDK sends the results to the orderer node for transaction ordering. After receiving the ordering request, the orderer node orders all the transactions and constructs blocks. The orderer then delivers the blocks to the committer node. The committer node verifies the integrity of the transaction data structure and the signature of the transaction. It also checks whether any of the transactions are repeated, whether all the endorsing nodes have their required endorsements, and whether those endorsements are qualified. In addition, the committer checks whether that version of the transaction result data is the same as the version recorded in the ledger. Finally, the committer updates the valid transaction data into the ledger. Ledger data is synchronized between peers through the P2P network they share. Huawei Cloud Blockchain Service lets you view, visually install, and instantiate chain codes. In addition, BCS supports multiple methods of invoking chain codes. The basic application encapsulation SDK can be used to invoke chain codes on remote peers. The application also can invoke chain codes through Fabric RESTful APIs, so that users don't need to integrate the SDK in their applications. Besides all of that, we also provide Fabric JDBC. This allows users to access chain code in a very simple way without having to constructing very complex interfaces in the code. You can select whichever invocation method suits your individual needs. When using the SDK, you can compile more complex chain codes. If you use JDBC or RESTful APIs, ledger operations are simplified. Currently, Huawei Cloud BCS supports Go for Chaincode programming, including the Go and Java versions provided by the SDK support community. In the future, we will also support more languages. You can submit the source code zip package after local coding. BCS also performs code compilation and containerization. If errors occur during the running of a chain code, you can check the chain code in the BCS O&M Center. Now, a question. Which interfaces need to be implemented during the development of chain codes? Answer. We need to implement the initiate and invoke functions in chain code development. In most cases, the initiate interface is invoked only once and is used to initialize ledger data. The invoke interface can be invoked multiple times though, to query or update the world state. That's why the invoke interface must be used to operate ledger-related data. Here are some standard operations on ledger data, including obtaining, updating, and deleting statuses, and complex query of statuses. You can find more details on this in the BCS API reference on the Huawei Cloud official website. We have provided a sample code for your reference. You can use code like this to implement chain codes.